Okay, today we're gonna just spend a short, basically day and a half, talking about a topic that we need a little bit of introduction to. It's not really that big of a deal, but it does apply some of the trigonometry that we've covered. We need to take a look at polar coordinates, and polar coordinates is a different way of writing your your coordinate grid. You know, Descartes came together and put the x and y axis together with our typical coordinate plane that we have. Why did he choose horizontal and vertical coordinates, x, y? We call those rectangular coordinates. Why not choose something like polar coordinates? So there's all sorts of different ways of representing points, locations. This is one. So a polar coordinate, we always plot theta first, then the r value. So it seems odd, but you know, when you do x, y, you first move horizontally, then vertically. But in this situation, generally we try to do the angle first, then the r value next. So in order to make this easier to plot, we look at this type of a graph. So this is pulled kind of from our unit circle where we have values that we know quite easily and understand. You want to guess what angle this is here? 30. Yep, so if we're in radians, this would be pi over 6, pi over 4, pi over 2. Okay, so I think you have that. So now as we go to work, we will plot 3 pi over 4, and then we will rename it. So first, I turn an angle of pi over 4. So it will be extended 3 units in the pi over 4 direction. So if I then move 3, 1, 2, 3, that's where I would finally plot it in that direction. See that? Now I'm going to take that and I'm going to rename it. For example, instead of calling it 3 pi over 4, I'm going to call it 3, but I'm going to rename the angle. I'm going to use that angle. Wait, know what angle that is? Negative 7 pi over 4. You can see that this coordinate is written as 3, negative 7 pi over 4, and as 3 pi over 4. Those coordinates are the same. I'm now going to do something that you may not like, but it's part of the deal. I'm going to create a negative radius. A negative radius means that we move in the opposite direction from the angle. So for example, if I had negative 3 pi over 4, instead of moving 3 units in the pi over 4 direction, I would move 3 units in the opposite direction. So what I would like to do is, instead of arriving at this pi over 4 position, I would like to arrive at this position and then move in the opposite direction. What would that angle be right here? I have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Negative 3, 5 pi over 4 would place you at that same position. This one? Try it again. 5 pi over 4 brings me here, right? Instead of extending 3 units in that direction of the angle, the negative means I move it in the opposite direction by 100. Okay? negative 3, what I'm going to do is I'm going to traverse there. Okay. Tell me what angle that is. Negative 3 pi over 4. And so therefore, those are 4 coordinates that look different, but in fact, they all plot the exact same line. So we're going to practice this a little bit. What I would first like you guys to do is you have 4 graphs here. Question? Yes, I'm sorry. In the directions, I should have said rename it 3 different ways. I actually used to do then a 4th one, but it really was never required of us. All right, so practice on your own. Here's what you're going to do. You're going to put 1, 3 pi over 4 on the first one, 3, negative pi over 6 on the second one, negative 3, negative 3 pi on the third one, and negative 4 pi over 4 on the fourth one. And after you plot it, if you're confident in your plotting, you can come up and put it on the board so we can all look at it. And if you're incorrect, we will still applaud you for your excellent efforts. Good job, folks. Did you get notes? Oh, it's fine for you. What you want to do now is you want to rename them. And here's how you're going to rename them. You're going to rename this first one, so instead of a 1, it starts with negative 1. You're going to rename this one, so instead of starting with 3, it starts with negative 3. This one, instead of starting with negative 3, starts with positive 3. This one, instead of starting with negative 4, starts with positive 4. Okay? So see if you come up with the angles given those different radius values. No. You're fine. There's a spot for test back there, and then here. Okay, here we go. If you have negative 1, then what I want to do is I want to get to this spot right here. And so there's 2 ways to do it. You could either do negative pi over 4, or you could do negative 1, 7 pi over 4. Either one will get you to that spot. Here, you want to get to this angle right here, which is 5 pi over 6. Or you could have negative 3, negative 7 pi over 6. That's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. I mean, you're 30 degrees back of 180, so you know it's 150 degrees. So you convert that to 5 pi over 6 then. What? So pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6. Okay. All right, this one's easy. I would just call it 3, 0, or 3, 2 pi, or 3, negative 2 pi. Any of those would work. And then we're going to do a positive 4. So you're going to go 4, 5 pi over 4, or 4, negative 3 pi over 4. Yes, this does come back to the units or your knowledge of the degrees of freedom. Okay, I'll flip it over. Okay, what we need to do now is we need to convert. We have x, y. That coordinate has a distance r from the center and an angle of theta. Does this look familiar? It should. So what we want to do is we want to be able to try to convert to polar. So we want to be able to find out two things. We want to know R, we want to find theta. Can somebody tell me how could I use X and Y to come up with R? Very good. R is equal to square root of X squared plus Y squared. Just like from the last unit, we did square root of A squared plus B squared. Same type of thing. And then in order to find theta, we solve tangent of theta is equal to, anybody? So B over A, we're going to use Y over X. We solve that argument. Now converting polar to rectangular, we want to be able to come up with X and come up with Y. Can somebody give me an equation that relates X, R, and theta? Cosine of theta is equal to, and sine of theta is equal to Y over R. So therefore, if we multiply both sides by R, we get X is equal to R cosine of theta, and we get Y is equal to R sine of theta. So these will be our conversions back and forth between polar, rectangular, rectangular, polar. So now we're going to do two problems that you're very familiar with from previous times. Convert 4 2 pi over 3 to rectangular form. So I need to come up with X equals and Y equals. Well, X is equal to R, which is 4, times the cosine of 2 pi over 3. And Y is equal to 4 times the sine of 2 pi over 3. Do I agree with where I came up with those formulas? Okay. So we take the R value, so this is R and that's theta. Yep, this is a polar coordinate. We're going to turn it into geometric form, rectangular form. Okay, so 2 pi over 3, I'm going to find some exact values. Can somebody tell me on the unit circle, we know that terminal point for 2 pi over 3? 2 pi over 3 is how many degrees? 120, so that leaves me with 60 left over. So if this is 1, this is a half, and this is root of 3 over 2, so what's my terminal point? All right, so cosine is the x value or the y value? Yep, so we got 4 times negative 1/2 is negative 2. And 4 times the root of 3 over 2 is, so the rectangular form is negative 2, 2 roots of 3. That will be in the same position as the polar coordinate. I'll give you a much better understanding. Polar form allows us to work through function issues that we otherwise maybe couldn't. So, and we will end with example 3. It says find the polar coordinates. So I need to find R. How do I find R? Square root 18 is? I find theta. Tangent of theta is equal to -1. Which quadrant am I in? 4. 45 degrees. So what's the angle then? That's the, I'm wondering the angle. So 45 back from 360 is 315, which is 7 pi over 4. So theta is equal to 7 pi over 4. So my polar form is 3 roots of 2, 7 pi over 4. That's the polar form of this rectangular form. Yes, that would be an option as well. Somebody brought that up the third hour. But the book very well may specify that the angle needs to be between 0 and 2 pi. So if it does, then you would not want to write negative pi over 4. But you are right that that's another way to name it. There's many ways to read it. So let me give you your assignment. Is your assignment 1 through 4, 7 through 10, 13 through 16? Yes.